Astronomers have detected a structure made of iron atoms in the inner region of the Ring Nebula that we have never seen before. This structure appears like a bar, approximately 3.7 trillion miles, 6 trillion kilometers long, is composed of ionized iron atoms, meaning iron in a plasma state. Stands out because other elements are not aligned in the same way, making this iron structure uniquely noticeable. The discovery was made as part of a European-led astronomy research project using WEAVE, a new instrument mounted on the William Herschel telescope in La Palma, Spain. The study was published in the journal Monthly Notices of the Royal Astronomical Society. The scientists who worked on this structure include, in particular, Dr. Roger Wesson, Cardiff University/University College London, Professor Janet Drew, University College London, the WEAVE project research team. Although the nebula has been known for many years, the teams that revealed this structure and produced detailed spectral mapping did so by re-observing it with modern spectroscopic methods and next-generation instruments. How was this structure observed? Thanks to WEAVE's LIFU, Large Integral Field Unit mode, the research teams were able to spectrally separate and map the light falling on each individual spatial element. They scanned every point of the nebula in detail. As a result, a distinct bar emerged where light specifically associated with iron atoms was concentrated.
Why is its origin unknown? There are several theories about where this iron bar came from, but there is still no definitive answer. 1. The remains of a vaporized planet? Some astronomers suggest that this concentration of iron could be the result of a planet being destroyed during the star's red giant phase. There is a theory that the destruction of an Earth-like planet could release this much iron into space. 2. Material coming only from the star? Alternatively, this iron may have formed as a result of the material ejected into space when the star died, somehow separating and behaving in an unusual way. However, the details of this explanation are still not clear. Some researchers also emphasize in theory the fact that iron atoms appear so distinctly alone in a bar-like structure in space is not something expected according to standard physics. For this reason, both the planet hypothesis and other possible processes remain subjects of ongoing debate. Why is it important? This discovery opens a window that challenges science in two major ways. Even a classical astronomical object like the Ring Nebula still holds unknown aspects. Planetary nebulae may provide new clues not only about stellar evolution, but also about how the death of planetary systems influences the distribution of elements in space. Technical analysis of the iron structure in the Ring Nebula. First, the object, Ring Nebula M57. This is a planetary nebula, meaning it formed when a sun-like star expelled its outer layers into space as it died, creating an expanding shell of gas. At the center, a white dwarf core, surrounding ionized gas, shock waves, effects of magnetic fields. How was this iron bar detected? The discovery was made using the William Herschel telescope in La Palma, Spain, equipped with the WEAVE instrument. WEAVE is an integral field spectrograph, IFU. This means, instead of producing a simple pixel-by-pixel image, it creates a chemical map based on the wavelengths of light, separating the incoming light spectrally to reveal the composition of the observed region. How does a spectral map work? An IFU system produces 3D data: x-axis spatial position, y-axis spatial position, z-axis wavelength, color. From this data cube, a hydrogen map is extracted, an oxygen map is extracted, a nitrogen map is extracted. Iron emission lines are filtered separately, and this is where the surprise appears. Specific wavelengths emitted by iron ions, especially the Fe2 and Fe3 lines, are concentrated in a long linear structure. Other elements are not aligned in the same way. That's why a bar-like structure emerges. A striking, isolated concentration of ionized iron, unlike the surrounding material. Is this structure solid? No, it is not solid metal, not a block of iron. Ionized iron atoms in a plasma state. The density is still extremely low, even more rarefied than a vacuum chamber on Earth. When we say it is made of iron, what that actually means is most of the light emitted from that region comes from iron ions. How is the mass calculated? Using spectroscopy, the brightness of emission lines is measured. The electron density is estimated. The volume is calculated. The number of atoms is derived. Number of atoms times mass of an iron atom equals total mass. These calculations show that the amount of iron is more concentrated than what would be expected from a typical nebular distribution. Why is it strange? Normally, in planetary nebulae, heavy elements are distributed homogeneously. Shock waves expand in a roughly spherical pattern. But here, there is a linear structure. Only iron appears strongly concentrated. The geometry is not symmetrical. This three-part combination does not fully fit the standard model. Possible physical scenarios. 1. Star-planet interaction. A planet with an iron-rich core may have been torn apart during the star's red giant phase. 2. Magnetic channeling. The star's magnetic field may have directed iron ions along a single axis. 3. Shock compression. Previously ejected gas may have been compressed by an internal shock wave. Where was the study published? The research was published in the journal Monthly Notices of the Royal Astronomical Society. This is a serious, peer-reviewed scientific journal, not a popular media article. Scientifically, the most critical point. This discovery shows that planetary nebulae are more complex than we thought. The Ring Nebula has been known for over 200 years. But when you observe it with new instruments, the universe seems to say, "You still haven't fully figured me out. Maybe it is just a gas filament. Maybe it is the last breath of a planet. Maybe it is a missing piece in stellar physics." But one thing is certain, the universe is always stranger than what we think we know. And we are still only at the beginning.